In this video, I'm going to be showing you how to create orbitals using VMD. So you open your VMD application. You just need to do some settings depending on your style. I will be using my style here and how I like my structures to look like. This is taking a while. So you come to this VMD main right here. You go to display, you uncheck depth queuing, you change this to orthographic. Okay, let's just leave this now. You come to graphics, come to colors, to display. I like my background to be white, so I will be choosing white. And I'm going to change the element colors. So in my structure, I have cadmium. I want it to be black. I have um I have chlorine. Trying to remember. I have chlorine. I will make it green. I have fluorine. I still make it green. I have seleniums. SE. So I would make that yellow. Yellow. And I'll just close this. So I'll click on File, New Molecule, click on Browse. You should have generated a cube file prior to this step. This is a cube file right here, which is an orbital file. So here, notice that I have orbital 319 and orbital 1266. This is because I carried out a spin polarized calculation. So this video can also be used for non-spin polarized case. If you were having a non-spin polarized case, all you have to do is you click on load and you come here, you see this open GL display. Then you come back here, you click on graphics, you click on representations, then you have this window. Now, first of all, you want to create, trust me, the atoms are already here, but they're not visible. So I typically like to use the CPK representation. So I start with the CPK representation and then change this to element because I already set what I want the element color, the atoms to look like. So that's why I'm changing the coloring method to element. You create another representation. You click on this and click on dynamic bonds. Now, dynamic bonds just means you're trying to put bonds into the system because remember, this is a visualization. So I would increase this distance. I'll increase the distance cutoff. It's how it makes the bonds. Right now it's too big, so I'm going to reduce it a little bit. Yeah. Now the bond radius is too thick, so I would reduce the bond radius here. You can see. Yeah, that looks good for now. Then create another representation. Drawing method, I choose isosurface. Isosurface is how you plot the electron density. That's the orbital. So you change coloring method to color ID. Now you set your ISO value. ISO value is just how much orbitals you want to be displayed. So I usually use 0.02 for myself. And then you come to draw and change this to solid surface, change show to isosurface so that you can see it. Now, I typically like to use transparent for my system. Depending on how well you get used to this, you can decide what you like your orbitals to look like. So remember that you have only created a positive wave function. Remember that electron density or orbitals is a representation, is solving for the wave function in your system. So this is the positive side. And then you click on create rep again, change the ISO value to minus, make sure it's the same number, and then you make this 1. When you remember that when you put the minus here, you have to hit enter for it to show up. So now you have blue and you have red. You can actually change these colors, but I like these colors and I'll keep them. Now to make it a little more beautiful, I would come back here to display, change this to depth queuing. Can you see that the atoms are now bolder? And change this to orthographic just because I like it to look this way. Now remember that this will usually be the end for non-spin polarized case. You just take a screenshot and use it like this. But if you have a spin polarized calculations like I do, and you have 2 orbitals, this first one will be your alpha orbitals. Now you can delete this, what you currently have, and then upload, click on browse and upload your photo, the same orbital as before, the same cube file as before, upload it again. Now select the beta orbital and click on load. Take a little while. So here is your beta orbital. Now the reason why I did not delete the first one is because I want to overlay my alpha and beta orbitals on top of one another. I have had instances of a paper where I had to plot them separately, the alpha and the beta. Just do the same thing like you did for the alpha, do for the beta. But right now, I'm making slides for orbitals that I want to overlay. I don't want them separated. So you come back to this window here. As you can see, if you click on this drop-down box, this 0 is the one you already have plotted. This 1 is the one you need to plot, which is the beta. So you do the same thing all over again, CPK element. You click on create rep. You click on dynamic bonds. You create rep. You click on ISO surface. You change this to color ID. Change this to transparent. Remember that this is for the negative wave function and this is 1. So you create rep again. You make this plus, hit enter. Make sure you remember to change this back to blue. So now I have overlaid both my alpha and beta orbitals on top of one another. So this is how you plot orbitals, molecular orbitals, transition orbitals, spin density orbitals, any type of orbitals. This is how you plot, this is how you visualize them using VMD. Let me know if you have any questions in the comment section. Thank you.